Here we've created a full replication of a real RFID access control system. We have a reader on the left, our middleman sniffer in the middle, and then a replication of an access control server on the right. In between, we've coded real Wiegand data lines. So we've been doing bit banging on these chips to generate 32-bit Wiegand data for these chips to read. And we follow all the same Wiegand protocols. So we modulate the pulse width and pulse intervals according to their timing specifications. What we have right now is we have a cloud database that shows information of what's happening here. So we have a couple tags. This is a good tag, so it has valid keys that the server over here has that can open the door. So when I present this to a reader, it'll open the door. It goes through our middleman, opens the door. As you can see, he has no sound and the LED goes off. We also have a bad piece of data. That won't open the door. That's not data that's in our database. Over here, we have an example of a malicious tag. Basically, this has a UID on it that when parsed by our middleman will output a good UID that will open the door. So if I scan this, it's going to open the door, and crucially, you can see the UID output on our screen here. On the left of the screen, we have the UID output of whatever I scanned at the reader, and the UID output of what the chip outputted. So this is essentially replaying other types of tags, and we can specify this in the database of the chip. We are using all ESP AQ66s here, and they're all connected to the cloud, pulling database information and pushing device information. In addition to that, we don't even need a tag. Since this is connected to the cloud, we can remotely perform a replay attack simply by pressing a button that pushes to our middleman. If I press this button, you'll see it sends a command over the cloud to send valid card data that we know will open the door. That's a replay attack. It's a great way to infiltrate an access control infrastructure when you don't need to be at the physical site. Another one of the attacks that we can do is a DOS attack. So we can effectively just not let people in based on their UID. So you see, if I turn off the DOS switch here, this piece of good data will open the door. If I turn on the DOS switch, that will send a command into a microcontroller here that will alter the data from good tags to zeros, effectively not letting people into the system. Same tag, I just switched a switch on our server over here. And you can see the UID at the beginning is the same, but what the microcontroller outputs is zeros. And because of that, it will not open the door over here. So this is a great representation of a real access control system. We've implemented the full Wiegand interface using the exact data structure that we use to convey this information. It's not a representation. It's not like a child's toy. This is exactly how these systems work. Real Wiegand interface, real reader, real mock-up access control infrastructure over here. So we've also implemented biometric authentication to prove some points about how this systems can be insecure. So we have a secure mode that when we enable it, it's a command to our infrastructure over here that opens the door that requires biometric authentication. Effectively, two-factor authentication to open the door. So you'll see my good tag here, when I turn secure mode off, it will open the door. When I turn secure mode on, what's going to happen is that is no longer going to open the door. We need a fingerprint in order to do that. So my cameraman here is going to put in his fingerprint. Now I'm going to scan my tag, and that's going to open the door. So what happened there was his fingerprint was set up into the cloud server that the infrastructure is talking to, and it was verified that his fingerprint matched the UID on his card. You can see normal cards don't work. My finger ID is not mapped to his, so that's not going to work. And another way we can break this, even though we're solving the problem of the middleman with a security mode, with two-factor authentication, it's just by performing a DOS attack on top of that, using the middleman. So in this case, even if we do biometric authentication, we'll have my cameraman come over and scan his finger. scan the card, it still does not work. Why does it not work? As you can see, our DOS attack outputted 0 data on the right side of the middleman, effectively eliminating any sort of card data or authentication that the infrastructure does. So this is a full-scale working model of RFID infrastructure for access control, implementing full Wiegand architecture. So yeah.